This is the first video of a sequence that teaches you how to use vector autoregressive models for multivariate modeling of risks and expected returns. The sequence will teach you how to set up an empirical risk model that accounts for conditional covariation among different risk factors. And this video here provides you some motivation and some definitions. So let's start. A Varma PQ model is simply a vectorized version of an Varma PQ model. The additional degree of complexity is that different variables are allowed to co-move with each other. Varma PQ models are heavily used in empirical macroeconomics, in macrofinance, and investment management. They allow a quick glance into how a dynamic system behaves. Now, these Varma PQ models are also useful for tactical investment management. They allow you to answer questions like, how are equity, bond, and option markets responding if the central bank increases the policy rate by 25 basis points? Or, how does my portfolio risk change if inflation increases by 0.5% and unemployment drops by 0.2%? Or, how does the value of my multi-asset portfolio change if market risk increases by 1%? Now let's connect back to what we've already known. We have already talked about a return forecasting model where returns are assumed to follow an AR1 process. So the data generating process would look like as follows. The return RT is decomposed into the predictable part mu t minus 1, it's predictable as of ft minus 1, and there's the unpredictable part epsilon t, which is white noise. And the AR1 specification says that the mu t minus 1 is a function, a linear function of the past return. Now, within a sufficiently complex dynamic system, the mu t minus 1 of one variable depends on past shocks of other variables. In order to account for such dependencies, one has to work with vectorized autoregressive models. And we will call such models simply VAR models.
Got feedback? We would love to hear it. Please drop us a line. And if you liked the video, give it a thumbs up. And don't forget to subscribe to the channel.